Hello everyone. In today's class, we are going to discuss Lenz's law. In our previous class, we were talking about Faraday's law of electromagnetic induction, and we have seen an experiment that was conducted by Faraday. According to Faraday's law of electromagnetic induction, the induced EMF E can be written as E is equal to N into d phi by dt, where N is the number of turns of the coil and d phi by dt is the rate of change of flux, right? Now we are going to revisit the experiment. So this was the setup for the experiment. Here is a coil which is having n number of turns, and this is a magnet. Okay, so first I will insert this magnet into the coil, and I can see a deflection in the galvanometer. Then I will take back the magnet and I can see a deflection in the galvanometer in the opposite direction, right? So according to Lenz's law, the direction of induced EMF in a coil is always such that it will oppose the cause. So it means that whenever the magnetic flux link with a conductor or a coil, it will induce an EMF. The direction of induced EMF is in such a way that it will oppose the cause. That is, it will oppose the whatever is causing the induced EMF. Okay. So here what happens is, when I am going to insert this magnet into the coil, so here what happens is, when I am trying to insert this magnet into the coil, the flux by the magnet will be cut by the coil and a current will flow in this coil. Okay, so basically this is a coil, and when current flows through the coil, it will become an electromagnet. So the current will be flowing in this coil in such a way that this end of the coil will become a north pole and this end of the coil become a south pole. Okay. And why this happens? See, here the coil is cutting magnetic flux because we are trying to insert this magnet into the coil, right? So the coil will try to make a north pole here so that it is opposing the insertion of the magnet. Okay, so that is why the current flows in this particular direction so as to make this side north and the other side south. Okay, now I have inserted the magnet. Now I am trying to remove the magnet. Okay, so now the flux are being cut because I am taking the magnet out of the coil, right? So in order to oppose that, what the coil does is, it will make this side a south pole and this side north pole. So what happens if this side becomes south pole? North and south pole will attract each other, and that will reduce the rate at which the magnet is being withdrawn. Okay, so that is why the current in the coil is changing the direction. Okay, so according to Lenz's law, the direction of the induced EMF in a coil or a conductor is always such that it will oppose the cause. So I hope everyone understood what is Lenz's law and one application of Lenz's law. We'll see you in the next class. Thank you. So I hope everyone understood what is Lenz's law, and we have seen in this experiment how the two poles of this coil is getting changed when we are inserting and taking back the magnet. That's all for today. Thank you.